Hey guys, Mr. Brading back here to talk about the first physics talk, Newton's second law of motion, and to just kind of go through it. And hopefully you have already watched the Newton's three laws of motion and the vocabulary video. If you haven't, go back and watch those first. I go over those in a very basic way and break them down for you, Barney style. Okay, so anyways, in the physics talk, there's a lot of pretty good stuff in here that's going to solidify what I already discussed in my other videos, and I'm just going to kind of quickly skim through this because I just want to kind of get to some of the things that I haven't touched on yet with the other videos. So again, here's Newton's second law. There's an equation for the law, and I'm sure a lot of you have already seen the circle, the pi, or the pyramid triangle that tells you what to do with each of the three variables. But ultimately, we can pretty much mathematically create any one of these if we just know one. And usually if we just know F equals ma, because that's the easiest one to remember, we can get A equals F divided by M and M equals F divided by A. So let's see. Alright, so here's a new piece here, a Newton. A Newton is a force that is pretty much what we, in the science community. It is a standard international unit, and it's just pretty much the expression of saying the accelerating an object that is 1 kilogram 1 meter per second squared. Alright, and so rather than saying 1 kilogram times meter per second squared, we just say 1 Newton, and that makes it really easy. And an example of this, let's say if you're going to pick something up against the force of gravity and the mass of it is 1 kilogram, you're going to have to use a force of 10 newtons. The reason why is because you have the force of gravity pulling down at a rate of approximately 10 meters per second squared, and you multiply that by the 1 kilogram and you get 10 newtons. Okay, and so we can also mass things on Earth according to the force of gravity, and so pretty much all you're doing to find that is multiplying the kilograms times the number of newtons. So again, a 5 kilogram object is going to have an attraction toward Earth of 50 newtons. And again, I already talked about unbalanced force and where there's acceleration. That has to do with Newton's second law here. Calculating Newton's using Newton's second law, they use some pretty bogus numbers here that seem a little bit complex. So let's simplify this. I'm going to go ahead and pull up this some pieces here so we can see. So now I can actually write on the computer. Alright, yep, there we go. So they say as a result of a serve, a tennis ball 58 grams accelerates at 430 meters per second square for a brief period of time that it's in contact with the racket. So let's just imagine the mass is 100 grams because 58 is a pretty bogus number, like I said. And let's say it actually accelerates at a rate of 400 rather than 430. That way we can do the math in our head. We don't have to break out a calculator. So if we were to actually calculate this, so let's first write down the force equals mass times acceleration equation. That's usually our first step. Write down the equation we're going to use. Okay. Now we need to actually change this equation up because we need to get, we know the acceleration. Okay. We know the mass, and it looks like force equals ma. Force is already by itself. Okay, so we don't need to manipulate any of these variables. Now we write down all the missing variables. So mass and we know mass, we got mass up here, it's 100. Okay. And we need to know acceleration as well, so we write down A equals. Again, we come up here, we look, okay, yes, acceleration is 400 meters per second squared. Alright. Now with the mass, because it's in grams, we want to change that to kilograms. And the easiest way to do that is just move the decimal to the left 3 times. 1, 2, 3. So we have 0.1 kilograms, and the acceleration is 400 meters per second squared. Alright, now what we do, the next step, after we write down the known variables, we plug those numbers in. So now rather than writing f equals ma, we replace the m with the actual value of 0.1. And this, when there is no space in between two variables, it simply means multiply. So anytime there's an x, a dot, or no space, that means to multiply. So we have 0.1 times the acceleration, which is 400. Okay. So in this case, 0.1 times 400, our force is 40 newtons. So if you were to break that down again into steps, the first thing you do is you figure out which equation you're going to use. Okay, in this case we're looking for force, and so we use F equals ma. The reason I know that it is F equals ma is because the F is on the equals left of the equal sign and it's by itself. If the F is not by itself, then we need to make sure that it gets by itself, or whatever we're trying to solve for. We want it by itself on the left of the equal sign. Okay. The second thing we do is we write down all the missing variables. Mass and acceleration. Mass equals, acceleration equals. After we've done that, we come up to our word problem and we figure out what those variables are equal to. So in this case, okay, as a result of the serve of tennis ball's mass, okay, the mass is 100 grams. So we put that down here. And then we find acceleration. Oh, it accelerates at 400 meters per second squared. Okay, let's put that down here. Once we have found all the missing variables, we can easily solve. To solve, replace the letters, okay, with the actual numbers, and then do the math. Okay, so force equals 40 newtons. And we can do that pretty much with all the equations. Those 4 steps, if you do those with any equation, you can pretty much do any of the math inside this classroom. Alright, let's keep going down a little bit. Alright, so we know how to calculate now. Alright, they give us another problem here. Let's just kind of go over it again, just so you guys can have a little bit of practice. So let's erase all this junk. Whoop. Erase, 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 erase. And erase. Alright, so first you read through it. Alright, what are we looking for? So a tennis racket hits a sand-filled tennis ball with force of 4 newtons. Blah, blah, blah. What is the acceleration? Okay, so we write acceleration equals the force divided by the mass. And I just remember that. But in any case, if all you know is, let's say, we want to make another one up here. If all you know is F equals ma, no, you piece of poop. Okay, there we go. All right, so F equals ma. We want to get the a by itself. Okay. What you want to do is, if these two are being multiplied, let's say a is being multiplied by m right now. If you do the exact opposite to the other side, so f divided by m, and then divide this side by m, And what that'll do is the m's cancel out, the masses cancel out. And so you get A equals F divided by M, and since the A is by itself, just flip-flop that so it's A equals F divided by M. Now, so we know A equals F divided by M. That's what we're going to use. We need to know force. We need to know mass. Alright, so again you read then you come up here, you read this. Oh, force is equal to 4 newtons. Mass is equal to 275 grams, and if we convert that into kilograms, we want to always convert it into kilograms. We get force of 4 newtons, mass of 0.275 kilograms. And so we then go and decide, okay, well, let's solve for that. And we get A equals 4, because we replaced the F with 4, the value of force, and divide that by the mass, 7.5. Okay, and they already kind of did the solving for us here. So acceleration equals 14.5 meters per second. Let's see if I can do this squared. There we go. Alright, that's probably enough examples of the math. Just make sure you're following those steps that I'm using. If you forgot them, make sure you rewind and pause and write them all down. Using measurements and calculations, determining the number of significant figures in a measurement. We're not going to worry too much about significant figures here. Gravity, mass, weight, and Newton's second law. What I'm going to do now is I'm going to kind of end this video, and then I'm going to go ahead and start up another one. This is starting to get a little bit too long, so if you need to take a break, and come back tomorrow and watch the second lecture.